All right, so you might be asking yourself, when would I need to find a missing angle or a missing side? So we've got some problems here about angle of elevation and angle of depression. So angle of elevation happens when you are looking up. So the angle of elevation you can see here is this guy is looking up. And so if he were to look straight, the difference in his line of sight is the angle of elevation. Angle of depression is when you're looking down. So this guy's looking down at this swimmer. If he were to look straight, the angle of depression is that difference in his line of sight by looking down. I'm just going to do two of each of these real quick so that you kind of get the gist. And if you have questions, definitely let me know. So I'm going to do number 11 and number 13 because in 11 and 12 you are given the angle and in 13 you're not. So in 11 it says the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? So that would kind of be like this picture that we have here. And so I'm going to draw that out myself. If I can get me a good triangle, that'd be great. All right, so let's see if I can get it to make me a triangle. There we go. Awesome. So, and obviously this is the right angle down here. And we know what? We know that the angle of elevation from a fishing boat. So the fishing boat, this is the lighthouse, like right here. And the fishing boat is out here. So the angle of elevation from a fishing boat to the top of the lighthouse is 5 degrees. So this angle is 5 degrees. The lighthouse is 161 degrees. So that means that this opposite side is 161 feet, I said degrees, above sea level. How far is the boat from the lighthouse? So you want to know this. How far in does that boat need to sail to get to the lighthouse? So we have a problem here where we are not involving the hypotenuse, so it is a tangent. So we're doing tangent of 5 equals 161 opposite over x adjacent, which is what we're trying to find. So that means that x would be 161 over the tangent of 5. So x is 1,840.2 feet. Don't forget to put feet on there. So that boat is quite a ways away from the lighthouse. So that's your answer there. All right, I'm going to skip 12 because it gives us that it's 44 degrees. This one is a problem where you have been given the opposite and you're trying to find the hypotenuse because it is somebody going down a slide. And so this would be a problem where you would use sine. And it would work out very similar to the tangent one. You would have to divide by sine of 44 degrees. Number 10, however, gives us 2 of the sides. So I'm going to make a triangle because I know I'm going to need one. And we know that this is the right angle. They're all going to have a right angle. So a 10-foot ramp is used to unload furniture from a truck. If the back of the truck sits 3 feet above the ground, find the measure of the angle that the ramp makes with the ground. Okay, so this is written like real crazy. So we know that the truck has a 10-foot ramp. Well, obviously that's talking about the hypotenuse because it's the only one that makes a ramp in the picture. And so what we're saying is the truck bed is up here 3 feet above the ground. And so then it says, find the angle that the ramp makes with the ground. Well, here's the ground down here. This is the ground. So the ramp comes down off the truck, like, let me get a different color. The ramp is here, and it comes down and hits the ground. So what is that angle when it hits the ground? So you're trying to find this theta right there. Okay, so we're trying to find theta, and the ratio that we know, so I'm going to write this down as I talk. The ratio that we know is opposite over hypotenuse. So that is the sine of theta, because we're doing opposite over hypotenuse. So that means to find theta, you're going to do the inverse sine of 3 over 10. So that looks terrible. So we're going to go over here and do second or shift. I think it's second on your TI-84s. And so that gives us inverse sine 3 over 10, or 3 divided by 10. So the angle is 17.5 degrees for this particular truck. Okay, so those were all, like, the ramp is going up from the ground. The guys in the boat are looking up to the top of the lighthouse. So that's the angle of elevation. Angle of depression, we're going to be looking down. So for this one, I'm going to do 14 and 16, because 14 gives us an angle and 16 asks us to find an angle. So we've got in 14, fire is spotted from the top of a 125-foot tall fire tower. So if you ever been to like a national forest, they do have these fire towers every so often, and there are guys that go up there and look for fires. That's their job. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? All right, so we need a triangle. And we know that this is the right angle. And we know that this side is the tower. So, like, there's a little tower here. And there's somebody. Oh, I forgot to switch back to pen. So there's somebody up here, looking out the tower. Okay, so the tower is 125 feet tall. Actually, let me change the color so that this stands out a little bit. Okay, so it's 125 feet to the top of the tower. And the angle of depression to the fire is 19 degrees. I've drawn my triangle upside down. I've drawn it like it was an angle of elevation, and it's not. So I'm going to have to start over. So sorry. I just realized I was like, oh, I can't make this look right. Okay, so let me redraw the triangle. When you have an angle of depression, think about this, that if you were looking straight out or down, that's how you make this. That is terrible. Okay. There we go. So it's like upside down from an angle of elevation. So sorry. So we have the tower is like right here. And there's a guy in the tower looking down. Okay, so the tower is 125 feet tall. The guy is looking down at the fire, so the fire is here, right? So this 125 is the same as this 125, okay? Because it's basically, the ground is here, it's making a square. So you can translate that if the tower is here and you're at the top of it, that it's also 125. If you look straight out and then went down, it's also 125. Okay, So you're up here and you're looking down at this angle, which is 19 degrees. How far is the fire from the base of the tower? So you're trying to find this, which is the same as trying to find this on the ground, right? But do you see how when I've redrawn this, like this is kind of what I had the first time? Like this is what I had the first time, and that can't be right because 19 didn't fit into my problem in the right place there. So that's why I had to redraw it. So, whew, lots of business happening. All right, so we are trying to find the tangent, not the hypotenuse. The hypotenuse is here. So we are not trying to find the hypotenuse. We are going to use tangent because we have opposite and we're trying to find the adjacent. All right, so we're going to do tangent of 19 equals opposite over adjacent. So this is one of those problems where you have to switch them. And then we'll find out what that distance is on the ground. So we're going to do 125 divided by tangent of 19. So that is 363 feet. So that fire is getting close, y'all. 363 feet is not very far when you're talking about fire. Okay, number 16, we need still one of these upside down triangles. So I'm going to go ahead and draw that. And this is, of course, the right angle in the corner. So we have Max sitting in the stands at a baseball stadium. So Max is sitting up here in the stands. He catches a foul ball and decides to throw it back to the player standing on first base. So the player standing on first base is right here. Okay, so Max has to throw this ball down to him. If the horizontal distance from Max to the player is 61 feet, so if Max could walk on air to the player, he would walk 61 feet. And the ball travels 76 feet to get to the player. So when Max throws it, he throws it along this hypotenuse, and it is 76 feet. What is the angle of depression from Max to the player? So what is this angle, in other words? So we have the adjacent angle and we have the hypotenuse. So adjacent and hypotenuse is cosine. So we're going to do cosine of theta. Theta. I just went to do equals right in there with it. And then adjacent over hypotenuse. So then to find theta, we're going to do the inverse cosine of 61 over 76, like this. And so then we'll find out what theta equals when we do that. So we're going to do second cosine 61 over 76 is 36.6 degrees. So that's what that angle from Max to the first baseman was. All right. If you want to do 15 and 12 and have me check them, I'll be glad to do that for you.